Kia ora ngā hoa mai. On this video today we're going to be talking about rocks, and this video is especially going out to Jude and Brenley, some amateur geologists in the making, and like I said, so we're going to be talking about some interesting rocks and some rocks that I have in my own personal collection, because I'm a bit of a nerd in that way. So stick around and I'll see you in a second. Now, if you're into rocks, most of you will know that rocks come basically in three classifications: metamorphic, sedimentary, and igneous. So igneous rocks are rocks that are formed during volcanic eruptions and things like that. Sedimentary rocks are rocks that are made from sedimentation where they're compressed in layers. And a good example of that would be sandstone, and a good example of igneous rocks would be pumice, scoria, okay? And then metamorphic rocks are rocks where they've gone through that pressure process, and the pressure has been so great that they have changed in their composition in some way or another. That's a really basic way of explaining it. But a good example of that would be diamonds. And diamonds start off as coal, and with pressure and heat, compression and pressure and heat, they eventually form over millennia into diamonds, or what we know as diamonds, which is why they're so precious. Now, some of the rocks that we're going to be looking at are predominantly sedimentary rocks. Now, and crystalline rocks at that. So the first one that we're going to look at is what's called a desert rose. Now, a desert rose is a desert rose is a slang term for a formation of gypsum. Now, you can see here that this gypsum has formed in these layers, and what's happened is, if I go in a bit closer, you can see that they're kind of stuck together with particulates of sand that have kind of bonded together like concrete, and you get these petals of gypsum in them. Now, you can get other variants of desert roses made of other crystals, but gypsum is probably the best well known because it makes the most defined petal. I'm not going to say the other one because I can't remember the name of it properly. It starts with a B, but they are a lot more soft and not as sharp an edge as the gypsum ones. So I inherited this one. This is a good one. The other one that I'm going to talk about, the other rocks I'm going to talk about today, are basically what's known as Viking sunstones, and I'm really into these, and I've done heaps and heaps of research into these. The first one we're going to look at is iolite, sorry. And basically, with this one, what happens is, as you turn it in certain kinds of light, and this one isn't a very good example, but it changes color depending on how the sun strikes it, and you can see when I turn it in certain angles, it kind of sparkles. Now, what happens is there's a polarity to this rock and the way that the UV light hits it, and so it starts shining depending on the way that the light hits it. Sorry. Another cool one that isn't known as a Viking sunstone, but it has a very similar effect, is labradorite, and when you turn that at a certain angle too, I wonder if I can get it to do it on this. It might be just because of the light. Yeah, you can see it gets a kind of a blue hue to it, and that's because of the light hitting it and the way that it reflects light and things like that. So I just like looking at this one. This is just for looking. Now, the two that I've saved for last are probably my most favorite rock of all, and they've been made famous because of television series and scientific research that's been done around navigation and the purposes that they were used for navigation. But these are my calcite crystals. Now, this one is optical calcite, and this one is called honey calcite or yellow calcite. And basically, the cool thing about calcite is they're polarized. So what happens is, when you hold them in the light at a certain angle, they polarize light. And what that means is that things appear doubled when you look through them, and then when you turn them at a certain angle, depending on where the sun is, if you line it up with the sun, that object appears again as one. And that's how they were used to navigate. So on a cloudy day before compasses, you would hold this up in the sky and turn your crystal, and depending on where the sun was above the clouds, the light would polarize itself, and you'd be able to roughly work out the position of the sun, and therefore work out your position and the direction that you were heading. Okay, and so it's hypothesized. Okay, it's an educated guess that Viking people used these because this is quite a common rock that can be found in Iceland. It's commonly known as Icelandic spar, but that's the particular rock that comes from Iceland. Generally, if it comes from anywhere else, it's just called calcite or optical calcite. Now, what I can do is I can show you an example of its polarizing quality. So when it polarizes the light, it's birefringent, which means it can make things appear as two. So a picture or an item will appear as two. So I'm just trying to I'll see if I can find a piece of paper. Here we go. This will do. Okay, so this is just a normal school notebook. Okay, and if I put that over there, you can see that it makes things kind of appear loosely as two. Now, that's the birefringence property. Now, a lot of people will go, oh, it's because it's a prism. That's why it's doing it. It's not, it's because it's a prism. It's because of the properties of calcite that it does that. A good experiment is if you can get your hands on calcite, is actually put on 3D glasses, because 3D glasses work on the principle of polarization, and you look through the calcite with 3D glasses on, and what happens is everything appears as one again, which is kind of a fun thing to do. This one is my favorite one. See, when you shine it through sun, it's beautiful and clear, just yellow, but I find that this one has a better birefringence than the other one. It's a shame you can't quite see it there, but you can see that things appear as two. But it's a really fun thing to look through too, and it's a beautiful rock to look at. Now, these rocks are, as far as I'm aware, a sedimentary rock. They're crystalline. One of the main features of calcite is when you break it, it shears off in these beautiful right angle shards. If I get close up here, you can see even the flakes of it are at right angles. So it naturally breaks off in this way. It doesn't break off like a normal rock would as like a chip. Okay, it breaks off like in these square shapes. Okay, these rhomboid shapes, and that's why they've got like that trapezium rhomboid shape, because that's how they break off. So this one's been heavily polished, this one's unpolished, it's just been cut. But you can pick these up from gem stores. Okay, I picked this one up from a rock shop, a gem store, Natural Wonders, Earth Treasures. And I picked this one up from Crystal Mountain. Okay, so they're relatively cheap because they're seen as not being a precious stone, but I think that's because also people don't know the proper qualities of them in a scientific way, and just how fun they can be to play with. So I picked this one up, I think, for about $5. So if you get the chance, these are a cool rock to play with. But if you've got any rocks in your own collection and you want to share them with me, put it in the comments line below. I always like hearing about rocks. I know it sounds silly, but I think they're quite cool. If you like this video, hit like. If you want to subscribe to the channel, because there's always stuff going on around here. But until next time, ka kite, and I'll see you next time on Mr. Ashley's Place.